Hello again, this is Jessie Johnson. This is part 2. Please go to part 1 if you have not. This is part 2 of what are the real stars in the heavens, the lies and deceptions you've been taught since childhood. In part 1, we left off at equal distance magnification. And I'm going to move the camera. Hold on, please. Equal distance magnification of Polaris, which is stated to be, which would need 20 to 28 million magnification if you were to see this object at their light year distances. The real distance of Polaris, I will tell you right now, the real distance of the real Polaris. This is Polaris, the North Star is 90 degrees north. Polaris is represented here with a right angled triangle. Every triangle has 3 edges, A, B, and C. Every triangle has 3 sides, hypotenuse and opposite side, and adjacent side. Now, number 1, we'll start with number 1. 1 degree is equal to 60 nautical miles. 1/60th of 60 nautical miles is 1 nautical mile. 1 nautical mile is 6,076.12 feet. Now we will go to the tangent of 89.99 degrees north, which equals 5729.577893, and number 5 is 5729.577893 times 6,076.12 feet, which equals 34,813,602.82 feet, divided by 6,076.12 feet, which equals 5,729.6 nautical miles. This is how high the Polaris North Star is above the Earth and above your head. This represents you. And you are standing right up under the Polaris Star. So A to B is 6,076.12 feet. A to C is 89.99 degrees north. B to C is the tangent of 89.99 degrees north, which equals 5,729.577893 times 6,076.12 feet, which equals 34,813,602.82 feet divided by, this is basic arithmetic, divided by 6,076.12 feet, which equals 5,729.6 nautical miles. And 7,729.6 nautical miles is equal to 6,589 regular miles. Just simply multiply the nautical miles by 1.15. You get 6,089 miles, regular miles, above the Earth. This is the actual height, altitude of the Polaris North Star above our Earth. I'm going to turn the camera right back again. Hold on, please. Now, to continue, the magnification needed by a refractory telescopic camera, such as the P1000, P900s, and so forth, telescopic cameras, because these cameras are 3-in-1. They are a telescope, they are also a still picture photograph camera, and also video cameras in one. And you can use a regular telescope, of course. The sun only needs 23x to 55x magnification. The moon only needs 21x to 55x magnification minimum. And Polaris Star, which is 6,589 miles distance away, only needs 65x to 130x magnification. Over that, you see much more detail, and all of these are an average of 50 miles in diameter. Now we'll go to how you focus your camera, whether it's underfocused, overfocused, or simply focused. We'll start with A. If your telescope or telescopic camera is underfocused, the stars looks like a point of light, or like the heliocentric stars. B, if your telescope or telescopic camera is over-focused, your images will look like a circle with no details, or almost no details, or a complete see-through image with internal reflections and refractions from the internal components of the camera itself, and distortions produced by the air pressures several inches, several feet, tens or hundreds of feet in front of the camera lens or the telescopic lens. We'll go to C. If the camera or telescopic camera or telescope is focused at the moon, sun, or stars, because the stars are thousands to tens of thousands of miles away and only take an approximate maximum magnification of 60x to 300x to present details and faint structures of stars with refractive telescopes, not reflectors. Now, I'm going to move the camera back. Hold on, please. Once again, if you have not seen part 1, please do so. These here are pictures taken with a telescopic camera, the P1000. These here is defocalized. They're defocalized in order to capture their colors. When you defocalize them correctly, they will look similar to this, where you can determine the colors. This is Vega star, this is Antares, this is Altair, and this is Arcturus star. Now, let's continue. These are stars in focus. They are in focus. They are not over focused, they are in focus. And you can see all of the brilliant extreme plasmic, extreme high voltage plasmic colors and frequencies of these systems. These are different stars, therefore they look different. They pulsate different, and so forth. They have different twinkles. Each one of them have a different twinkles. They do not twinkle the same. As a matter of fact, if they were all balls of plasmic, not plasmic, but balls of compressed fusion and so forth, they would have a completely consistent twinkle, every one of them, through our atmosphere. Here's more of them. I don't know which one this is, but here's the NASA type look stars. This is when all globe earthers tell you that your stars or your camera is out of focus. It's not, because they want you to make certain that your stars look like theirs, which is under focused. This here is focused. This here is under focused, where it looks like a pinpoint of light. Pinpoint of light. Once again, this is a Nikon 1000 camera, telescopic camera. This is in focus. This is in focus. This here is over focused. Pardon me, over focused? Yeah, that's right. This one here is over focused. In focus, over focused. Now, let's continue. I'm going to move the camera back. Hold on, please. Now, this has been part 2. Part 2 and part 2 of what are the real stars in the heavens. The lies and deceptions you've been taught since childhood. Now, join me on part 3, please. And share this video, of course, and have a fine day, and we will meet on part 3.